Mrs. Fraser here. In this video, we're going to talk about chemistry that you need for biology. And I know what you're thinking, but I took bio, not chemistry. Well, everything is made out of atoms, therefore molecules, non-living and living. So if we are going to study living things, we have to understand chemistry. This video is going to walk you through the chemistry that you really need to know to have a fundamental understanding of biology. Matter is anything with a mass and that takes up space. The smallest unit of matter are atoms. They are non-living. So when we start talking about living things, and we start talking about the smallest thing is cells. But when we're talking about living and non-living, the smallest unit are atoms. And if you remember looking at the periodic table, this is a list of elements, every known element, which is so crazy to think that everything that makes everything that we know to be true in this life are made out of something on here. I think this might be missing some, but in biology, we focus on hydrogen, carbon is a big one, nitrogen, oxygen, phosphorus, sulfur. We see potassium and sodium a lot too. Calcium. You could already see the pattern, and that is really important. And bio is finding these patterns. So let's remind ourselves of what atoms are composed of. You have a nucleus, and inside of that nucleus are the protons and the neutrons. Neutrons have no charge, protons have a positive charge, and then on the outside of the nucleus in these electron shells are the electrons with a negative charge. The number of protons are what give an atom or an element its properties. So this one, we can count, there's 1, 2, 3 protons. So this is actually a picture of lithium. Electrons are what are going to be in charge of bonding to other molecules and how these atoms behave and why they bond to other atoms to make molecules. Remember the saying, opposites attract and likes repel. So this means that positive are going to repel, or negative will repel. They don't want to be next to each other. Positive and negative charges, they are attracted to each other. So they're going to want to be close together. And this is important when we're talking about bonding. Let's look at this carbon atom here. So we see this is a drawing. This is the nucleus. It's not showing us the protons and the neutrons, but if this is a non-charged, so there would be, to make this carbon, this would have 6 protons, 6 neutrons inside of the nucleus, and we can count 1, 2, 3, 4, 5, 6 electrons. I don't know if you remember the octet rule from chemistry, but atoms like to have 8 electrons in their outer shell. And so carbon has 1, 2, 3, 4 in its valence electron. So remember the outer electron shell, and this little symbol here means electron. I'll write that. The outer electron shell is called valence shell, the valence electrons if they're outermost. And those are the ones that are going to bond. So carbon, it wants to have 8 electrons to be happy on the outside. It has 4, so it can either gain 4 electrons or it can lose 4 electrons. But what it's going to do, it's going to share to make covalent bonds. And so what's so cool about carbon is it has lots of bonding options. it can make lots of different types of molecules because of these 4 valence electrons. Let's talk about bonding. So we are going from, how do we go from just atoms, single atoms, to molecules? And we'll be dealing mostly with molecules in AP Bio. So there are some types of bonding we're going to talk about. These two, let me make this picture bigger. The first ones are covalent bonds and ionic bonds. Covalent bonds share electrons, and they are strong. Strong bonds. So if you look at this picture, these two atoms right here, this looks like hydrogen, 1 proton, 1 electron. Since they want to have a happy balanced outer shell, and in this case, since the number is not 8, the first shell is 2, they can share electrons, and now they're both happy with having the 2 electrons in their outer shell. Sometimes electrons, they don't want to share, they just transfer their electrons. When the electron is transferred, it is called an ionic bond. So here you can see that this atom is giving its electron to this other atom. Now this one is positive because it lost its negative charge, so it only has this positive charge, making it positive, a positive ion. And this one now has 2 negatives as opposed to the 1 positive, so this is a negative ion in this ionic bond. So ionic bonds transfer electrons. Let's look at a picture. Oh, sorry, okay, getting rid of that. Let's look at a picture of carbon. So carbon, here we see are 4, 1, 2, 3, 4 outer electrons. Here too, 1, 2, 3. We're going to name that one 4. So these 2 carbon atoms, this is a covalent bond because they are sharing this electron. And now you count it. This one has 1, 2, 3, 4, 5 valence electrons. So in this case, it's still not quite happy because it wants 8. So it will be able to make another bond here, here, and here. And look, if we count it, what would happen? If it bonds here, it would be 1, 2, 3, 4. Let me count that out loud, or let me write it. 1, 2, 3, 4, 5, 6, 7, 8. So then it would be happy. So this is what I was talking about. Carbon can make big molecules because look at how many other molecules it can bond to. So now let's observe this picture that I just blew up. Here we have a polar covalent bond. This word polar right here means charged. It has a charge. So let's look. These hydrogen right here are sharing its 1 electron with this oxygen. So this oxygen normally has 6 valence electrons. 1, 2, 3, 4, 5, 6. It's sharing with 2 hydrogen to make it 7 and 8. So the oxygen is happy, and the hydrogen with 2 valence electrons is happy as well. But notice that this oxygen has a lot more electrons than hydrogen. So over here we see this cluster of electrons, as opposed to the hydrogen, there's only 2 over here, and then over here there's not any electrons. So this is a partially positive side of this molecule, of this hydrogen, and this is a partially negative side of that oxygen because of those extra clumping of electrons. This is a polar covalent bond because it is slightly charged on both sides. If we look at this non-polar covalent bond, we have carbon, which we know has 6 electrons in its valence shell, and it is bonded with 4 hydrogen. But since there's not any extra electrons piled up anywhere, they are evenly distributed, it takes away having any type of charge. The charges cancel out. So this is a nonpolar covalent bond. Now let's look at these pictures. So this is sodium. This is chlorine. Chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. So to make chlorine happy, we just need to add 1. Sodium only has this 1 valence electron. It's easier to give it away than it is to get 7 more. So it transfers that electron to chlorine. So here's the thing. Now chlorine has, in this picture, chlorine has 8 electrons, but it still only has 7 protons, the positives. So those actually, the sign for proton is actually H+. I'm gonna write that up here. H+ equals proton. And that should make sense because it's a hydrogen that's positive. So that means it does not have an electron, because hydrogen only has 1 proton, 1 electron. If it's positive, it means it got rid of its negative. So just a proton. Since this chlorine has 8 negatives and 7 positives, it has a difference of an extra negative. So this is a negatively charged ion. Since sodium got rid of its electron, it has 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. I can't count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, I was way off. Has 10 electrons, which means it got rid of 1, so it normally has 11. So, which means it has 11 protons in the nucleus still. So this has a net charge of a positive. This is a positive ion. So we would connotate that as Na plus and Cl negative. Atoms with the charge. So the last type of bond, which is not actually a bond, it is an attraction, is called a hydrogen bond. And this happens between polar molecules. So the biggest one we are going to see in bio is water. Since water, I'm going to blow this one up, this picture up here too. Let's look at this picture. So if we look, oxygen, we already kind of saw this. It binds to that hydrogen, but you have the extra negative, the extra clump of electrons. So this is partially negative. These hydrogens are partially positive. So it is a polar molecule. And when you get a group of these water molecules together, the negative on the oxygen is attracted to the positive on the hydrogen, and they create this attractive bond, this force that holds them together right here. And those are called hydrogen bonds. Hydrogen bonds are weak. They can easily be broken, but they are strong enough to hold the water together. And our next whole chapter is going to be talking about why this is so cool and why water is so cool. So those are really the big chemistry topics that you need to have some background on as we move forward with biology. My next video will talk about how to read molecular structures. So stay tuned for that one.